So how does a beginner setup differ from a more advanced flyer setup? Before we get into that, let's just touch on helicopter control, or the actual control movements, just so you know yours are working correctly. I use a Mode 2 transmitter. All that refers to is which stick controls which function of the bird. Mode 2 here in North America is by far the predominant type of stick arrangement. I know in certain parts of the world, Australia, I know I get lots of comments from folks there, and Mode 1 is very popular for helicopter or RC heli control there. The only difference between Mode 1 and Mode 2 is your cyclic stick, which on a Mode 2 transmitter on the right stick, they actually split the two axes of the cyclic to both different sticks. So I'm not saying one way is better than the other. The one thing to know though is whichever mode you learn on, that's generally the mode that you're going to be flying with for your entire life. It's just very difficult to relearn on a different mode, and that's going to be determined probably from your first helicopter or radio, or if your instructor uses a specific mode when they're teaching you. But here in North America, Mode 2 is the most common. I just wanted to make you aware of that, just so you know when I'm moving my sticks which control functions they're going to be moving here. So on Mode 2, as I said, this is your collective and tail rotor. Collective and throttle up and down. This is actually one stick movement that is controlling two channels, so that's important to realize. There are two channel outputs being controlled by this one stick, and the reason there's two channels over just one and splitting it perfectly is so you can vary the amount of throttle and collective pitch command dependent on stick position, which is very important. That's what throttle and pitch curves are all about. Again, why computerized radios are so important, so you can set that up properly. For your collective pitch or your collective stick, the down stick movement will produce less angle of attack, so there's less lift. Up stick movement, more angle of attack, more lift. On most helicopters, this also means the swash plate will be in the down position with the stick down, and it will move up as the stick is moved up. Some helicopters are opposite of that. Some helicopters are actually, when the stick is up, the swash is down. It's still producing positive angle of attack though. It's just the way they've got the push rods and the bell mixing hooked up in the bell mixers, if you've got a bell mixed rotor head. So that's essentially your collective control. This is tail rotor or rudder, so left tail rotor, right tail rotor. I'm not going to get into how the pitch change on the tail rotor works, because it depends on which side of the boom the tail rotor is positioned on and which direction it's turning. The one I do cover it though extensively in my setup and tips book, so you know how to determine if your tail rotor is pitching the right way, and also if your gyro is correcting the right way for your tail rotor control. On your cyclic, and you'll notice in all my training videos that are coming up, I do refer to cyclic or the stick as cyclic. I try to use proper helicopter terminology. So for those of you who are still familiar with this, or call this up and down elevator, left and right aileron, I just use the term cyclic. So this would be forward cyclic, where the swash plate tilts forward. This is the front of the bird, by the way. Aft or rearward or backward cyclic. This is my left cyclic, swash is tilting to the left. Right cyclic, swash is tilting to the right. So just so you know that those are the directions you want to see the swash plate move and your collective pitch move when you're using your collective stick. So how does the setup differ for a beginner? If you'll notice here, this is my sport setup, where I'm producing pretty much as much negative pitch as positive pitch. This is so when I'm flying inverted, I've still got lift when I'm upside down as opposed to right side up. And you'll see the pitch range is quite extensive. For a beginner, I've got 3 flight modes set up here. Sport, beginner, and just general flight. But when I'm using this helicopter for training purposes, here's my collective range. Very, very much reduced over the much more aggressive sport range. And really all I've done here is I'm just using a small portion of the collective range where the helicopter hovers nicely at. And for a beginner, what that does for you is it gives you much finer resolution of your collective control. Your collective stick resolution is greatly increased. So one, if you accidentally give a little bit too much up, the heli isn't going to rock at 30 feet in the air. And boy, the new powerful birds will do that. And most importantly though, if beginners, it's so common and it's just natural reflex. If you feel panicked or you get into trouble, the natural reflex is to just pull down on your throttle and collective. And this is even more of a problem now with the small little all these small little micros out there, because you know, that's what you've learned on. That's how you when you get into trouble with those, it's one of the first things you do. So if you had a more aggressive collective range, if you did that, the bird is actually going to suck its way into the ground, and even if you're a foot off the ground, it's going to come down hard enough that it's going to damage it. So with a very docile range like this, that's not nearly as likely to happen. In fact, in my flight videos, I demonstrate this numerous times, where if you get into trouble and you make the natural instinct to pull down, the bird will come softly down, and you will see that. So that's how your collective is different. Throttle curves, you're not going to be producing as much power output. Obviously you're running less collective range, so you don't need as much throttle output on the high end. You're still going to run 0 throttle when your stick is in down position. For cyclic, cyclic range is greatly reduced over in beginner mode over when it's in sport or more advanced flying mode. So again, I've got this set up for dual rates, and again I go over all that in the setup book. But again, the whole idea is just to reduce the amount of output, so your controls are much less sensitive, so you don't over control it, so you don't get into trouble. Just makes it much more docile and more controllable to fly. You certainly don't need to be able to roll a helicopter onto its back in half a second when you're first learning to hover. And one thing I should mention with this hover collective, it is specifically meant for learning how to hover. You don't want to be flying circuits with this or getting into fast forward flight. And again, I cover that later in the videos. So let's get on to center of gravity checking. So center of gravity check, very important. Even if you've got your swash plate perfectly level, if your center of gravity is forwards or backwards of the main mast, obviously the heli is going to drift backwards or forwards depending on the center of gravity. To check it, really simple. With a flybar heli, you just pick the bird up so it can pivot on the flybar. The center of gravity on a helicopter is right through the main mast or main rotor shaft. As you can see right now, I've put training gear on this because obviously you're all going to be having training gear as you're learning. So you should have the training gear on as well when you're checking your center of gravity, just in case the training gear throws it out. Ideally it shouldn't, because the center of the training gear should be right underneath the main mast. But I've just done this for demonstration purposes. I've really moved that the battery pack far forward, so you can see the helicopter is tilting forward. What you'd want to see is the center of gravity nice, so the bird's nice and level. In fact, I could even move that back even just a little bit more. You don't want to touch the motor. This is a bigger pack though, so that you know, if anything, you want the heli to be a little nose heavy if anything, but ideally when you're learning you want it to be level, but that's certainly adequate, certainly good enough. With fly barless becoming so popular these days, I may as well talk about it, checking CG on a fly barless bird, since you don't have a fly bar to pivot on. No fly bar here to pick it up by. I talk about fly barless on my website, why I don't feel it's probably the best thing to start out with as for a beginner, just because, no, you can read it on the website, but a lot of people still start on it. There's nothing wrong with fly barless. It's a wonderful system. But of course, you can't check center of gravity the same way. You could try to check it by pivoting on the main rotors here. But a more accurate way, with the T-Rex 3G system, they actually come with a little T-fitting that goes on where the head button is. So you put this little T-fitting on here, and then slide the fly bar that you had on the bird through the T-fitting, and you can check the CG that way. You can also use that T-fitting to use as your sighting aid for your pitch gauge. What I like to do on my fly barless machines is, before I even put the head on, I just, assuming this is the main motor mast, I have the motor mast, or the mast and the bird obviously, and I pick it up with a small screwdriver through the blade bolt hole, and that will tell me if it's forward heavy or rearward heavy. So that's really all CG's all about.